Go. All right, let's look at number one. I'm recording this too, guys, if you need to look at it again later. All right, number one. So I look at number one, and the first step I need to do is look and see, well, does it match my situations here? If it doesn't match, it might be, I think actually these two right here are similar to what we did last section. So they're kind of different, okay? They're not kind of different. It just won't follow any of these three because I look and look, it's x minus 16 being squared. It's not x being squared and 16 being squared. That would be difference of two squares. You see how it does not match? You see how it doesn't match? Because look, this is the squared is applied to the quantity. Here, the difference of two squares is subtraction. We have that between the terms, but it would be the first term being squared, the second term being squared. We don't have that situation here. It's the entire quantity being squared. So this kind of problem, we're not going to be able to use the identities, but we're going to do this. We're going to say for number one that this is essentially just x minus 16 times x minus 16, right? We don't actually have to do our identities. We just have to do what we did in the last section. And this homework kind of covered both of them. If you didn't see that or you were confused, then all we have to do is remember when we have two quantities multiplied together, we're going to multiply the x, right? As if it was just the x out here, I'd multiply the x to the first term, and then we have to do the x to the second term. Let's do those first, and then we'll do the second part. Let's look. X times x. It's all being multiplied, so I know that's what I'm doing. And I'm going to end up with x squared. And then what is the next step going to be? Okay. And then I look here. I just did this one. I'm going to mark it as done. I did x times x. Now we do x times negative 16. Negative 16x. Is everyone okay with doing that? Doing the first half? We did this last time. Yeah, we've seen it before at least. It's not brand new. Okay. If it is brand new, hey, let's just get caught up. Email me. Let's set up a 9 a.m. to 9:30 check-in. We'll get all caught up in 30 minutes. Every student that's come for a little tutoring time, in a half hour, we get everything caught up. So I want you to think about doing that if you feel like you're not getting it. So hiding that won't help. I want you to really come out and try to at least ask me for help. Now look, we did the top two. We got x squared minus 16x when we multiplied x into both of the top terms. Now we have that second term. We have that negative 16x that we need to distribute. So first, what did I do? First, I distributed, I'm going to cover it, kind of. I distributed the x as if it was just x times that quantity. I did that and got those red values. And now I have to do the 16, negative 16 now times the quantity. You do them separate. First you look at this one. Can you see it? Ah, crap. First you look at the x, then you look at the negative 16. Now let's do it. Negative 16 times x, negative 16x again. All right. Lastly, negative 16 times negative 16, is positive 256. All right. So now all we have to do is combine the like terms. I think we can combine these two only because those are the only ones with the same either type of term or the same exponent, right? So watch. X squared minus 32x, because you're underwater 16 feet, you go down another 16 feet. You're at negative 32 feet, okay? Plus 256. Done. Okay, this is something, it's nice actually, I'm glad. So we're like reviewing the section before this. And if you're confused, now you know why. And maybe you know how to do it a little better, okay? All right, if there's issues with this, tell me in the chat, where did it happen? Was it distributing? Which I should mark these off to help me remember. Was it distributing? Was it combining terms? Was it organizing? If you're like thumb sideways right now, tell me in the chat so I can be a better teacher. All right. You're like, you're good enough. There's no chats. All right. Now, let's do number 2. All right, number 2 is just going to be very similar. So, Alicia, watch this. Number 2, right here, it's 4x plus 21 times 4x plus 21. It's not one of our identities. It, again, does not match any of our identities, which require that each of the values inside be squared. Okay. Now, this is the same as the last one. Let's do the second part of distributing. Okay. That's this part, actually. James, were you talking about combining? This is combining. Combine. This is distribute. Those are the 2 main steps. So let me know. Give me a hint on that. All right, we're going to multiply that 4x times the 2 values involved in the second quantity as if we didn't have this 21 here. Then I would just be multiplying it once, distributing, and then I'd be done. But we'll have to remember our next step because we have this plus 21 involved. Don't leave plus 21 out. All right, so look, 4x times 4x is 16x squared. Because look, 4 times 4, 16. X times x, x squared. It's all part of the same term. It's really just 4 times x times 4 times x, 16x squared. All right. Right. Okay. Gotcha. So if you just did this part right here, well, what we did right now is just the first little tie there. Now let's do the second, and then I'll have something to say here to you, James, right now. So look, right after this step, I have something to say. 4x times 21, it's going to be plus 84x. All right, we did this one. Boom, done. Now, looking at the rest of this, let's go with the next part. Because if it was just 21 times this quantity, I would distribute the 21. Because there's 2 different things in the first expression, yeah, I got to do both of them. So now I'm going to do 21 times 4x. This is the key thing. So if you just missed doing this, you only distribute the first term, no worries. Just do it again. It's good because you already know how to do it. You just have to do the exact same thing twice. Okay. So I'm going to go ahead and do now 21 times 4x plus 84x. Cross that one off. 21 times 21. What is that? It's not 4. No. 4. I don't know. Maybe 15 years ago. 441. Dang it. I'm so close. Plus 441. Thanks, Alicia. I'm just going to ask you. You need the surrogate calculator. All right, hey, look. These are the only 2 terms I can combine because the other terms are just a number out here and second power up here. These are both first power x's. So let's put our final answer, 16x squared plus 168x plus 441. Okay. So we got numbers 1 and 2 done. We got 1 and 2 done. Anyone else want to see another number? Because I think we're going to actually get into, that was like last lesson. Now let's get into what we're doing now. I can just go down these numbers, get through as many as I can. If you want that. You want me to just do as many? One sec. Do we have number 7 to do? One sec. I thought that was in the... It's 1 through 6 in the workbook. It's 1 through 4 in the book. So yeah, I'm not going to do that one. How about I just go through all the ones in the workbook? Hopefully I make it through all of them. Let's do that. All right, let's look at number 3. All right, number 3. Let me see what's going on here. One sec, where's that thing at? This thing always disappears. There you are. All right, let's look at number 3 now. And when I look at number 3, now we're starting to look like some of our identities. Now you may say, well, this isn't, 4 isn't being squared, so it doesn't, you might say, well, then it doesn't fit into our values here. So first I look at my identities. This one involves cubes, cube, cube. This one involves cubes, cube, cube. The difference of 2 squares is the only one that involves squares. So I'm hoping it's this. I'm hoping, right? So when I look at this for number 3, yeah, this could work. We have subtraction. That matches. We have our b value being squared. Yeah, I could see how this 4 is 2 times 2, 2 squared. So I'm seeing from there that could be a squared value. We're looking to see if it's a perfect square. If it's a perfect square, that's like 4, right? 9, 16, right? Those are perfect squares. 25, 36, 49. So those are our perfect squares. This definitely is the difference of 2 squares. That's the difference of 2 squares. Now what we have to do is we have to go in here and say, well, how does this work with that? Here's our identity, right? Here's our scenario right here. So here's what I want you to do. Now, I look over here, and my steps, I'm going to follow. Identify the polynomial identity. I did here. It's the difference of 2 squares. The difference of 2 squares. Okay. Now, what do I want to do? Step 2. Find A and B. Find A and B. Now, this is the hardest part because to find A and B, we have to first see that, well, this and this, if it is within our identity of the difference of 2 squares, then this first term is really our a squared term. This second term is our b squared term. And now we just have to figure out, well, how did we end up with those terms? And what are my a and my b value? Because I know my a squared value is 100x squared. My b squared value is 4, right? But how do we know what our a value is just alone? Here's my trick. Here's what you can do. To go from a squared to a, you have to take the square root. Square root. To go from b squared to our b term, we have to take square root. Square root. That's square root. There's like a stylized square root. Don't need that. No style necessary. All right, so let's see. I think taking the square root of 4 might be easier. The square root of 4 is 2. So I just found that. Now let's do this first term. Remember, first we look to see what identity it worked with. If this is the identity it works with, then I know that the first term must be my a squared term. So this is a squared. If this is a squared, what's a going to be? Let's do them in parts. What's 100? What's the square root of 100? Square root of 100. Show me on your hands. The square root of 100 is 10. So we end up with 10, but we can't forget about this. X squared. What's the square root of x squared? Show me on your hands. Square root of x squared is... Square root of x squared is... What times what gives you x squared? Wait, it's Monday. It's Monday. X. Good. Thanks, Alicia. When a squared is 100x squared, regular old a, taking the square root of a squared, is just 10x. Here's how we could test. 10x times 10x, that would be a squared. That would be a squared. I would get 100x squared. Yes, it works. If b is 2, Then b squared is 2 times 2. That gets 4. That's where I started. All right. So we got our A, we have our B, and now we're just going to fill in the blank. We can kind of turn off our brain a little bit when we get to this step. Don't turn it off. Just turn it off a little bit. Okay, don't turn it all the way off. So we're looking at the difference of two squares. So I'm going to write them out. The difference of the two squares, when we have it in this order, we're going to end up with A plus B and A minus B. Now let's take our A and our B and let's just put them in there. And we're done. That's it. Once you find A and B, you're in good shape. It's going to be plus in this one, minus in that one. So go ahead and put it in there and then tell me, let's see. In the chat, just tell me what the first quantity right here is going to be. What's the first quantity going to end up being? Just tell me in the chat. Because I know there's people out there in the world. Let's see. What goes here? A goes there. B goes there. A goes there. B goes there. The identity is really nice. With the identity, all we have to do is find A and B through using the identity and in some places square rooting, some places cube rooting, we'll see. So if I look here, A is 10x, B is 2. A is 10x, B is 2. Done. I'm going to take a wild guess and say that it's not wild. It's probably right. I think that the issue is going from A squared to finding what your A is, B squared to finding what your B is. Give me a thumbs up if I'm right about that. Is that what the hard part is? Going from A squared to A, B squared to B, figuring out what your A and B are from that equation? Yeah, that's the issue, right? We just need some practice. Need some practice. I almost feel, I'm just going to give you one here. I'm going to give you one other. What if you end up with this? Let's see. I just want you to find A and B. If it was x squared minus 9, what's your A and your B value going to be for this? Right down here. Right down here. What's your A and your B value going to be for this? We know it's a difference of two squares. So all we have to do is square root them. Close, Alicia. That's like the answer for like the second quantity. Now, what I wanted to see here is x squared, the square root of that is x. 9, okay, here's what you got to remember too. And this is really, 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 really key. Since we're dealing with the difference of two squares, we are assessing our b squared value separately from the subtraction going on. Okay, this subtraction here is not going to be viewed as part of the 9 because this is really our a squared, that's our b squared. So we're just looking to see, okay, subtraction is part of it. Subtraction is always in between them. But I'm looking here and seeing that, well, b squared to 9, b squared being 9, then b is going to be 3. So my final answer is going to be x plus 3, x minus 3. And that's for this problem. Okay. Okay. See you tomorrow. See you tomorrow. All right. We only have 6 minutes. I want to do a few more. I want to do at least one of each of the examples to come here. So I'm going to kind of move the pace a little bit more. You can ask for a screenshot after class. Okay. So get that done really quick. You know what? I'll put this over here. Hey, look at that. Improvising. No way. All right. You guys only had to do like 1 through 4, right? Easy for me to say. 1 through 6. That's why it's hard for me to say. Okay, this one, 3 we already did. This one, How interesting. That's close to the one I did here. This is the difference of two squares as well. I'm just going to help you out by saying, okay, well, if a squared is x squared, then a is just x. B, in this case, what's the square root of 81? 9. So I could see number 4, just because I've memorized the function here, I know it's just going to be x plus 9, x minus 9. The difference of two squares is easier to remember. Because remember, if you're like, well, how did you know to plug them in like that and all that? You're going to have these identities. You're going to have these identities available. The identities tell you where to plug things in. As long as you just find your A and your B, you're golden. A and B, once you find those, you just got to plug it into the other part of the identity. So I'm going to go ahead and keep going. Let's look at number 5. All right. Now, number 5, what do you see first off that's different? Well, you're like, Mr. Precise, we can't see. Oh, now no one can see. Now 40% of the people can see. All right, there we go. What's different between this problem? What do we see now that makes it more complicated? What's involved? Show me on your hands. 3. Cubed. It's cubed. But that's okay, because first I'm looking for clues to see which of these properties I'm going to use. Let's see. Is it the difference of 2 squared? No, that has squared values. It's cubed. Let's see. Is it the sum adding 2 cube values? Let's see. Yeah. It's the sum of 2 cubes. So it's a sum of 2 cubes. So I'm just going to go ahead and see if I can do it like that. Can I just keep it there? Yeah, I can keep it there. So that's the sum of 2 cubes. And now let's look. We have 27x to the third plus 343. Here's the thing. This is our a to the third plus b to the third. So if I want to find out what a is and find out what b is, look what I have to do this time. I have to take the cubed root. The cubed root. Because if you're going from a cubed to a, you have to take whatever term is identified as a cubed, which is this 27x to the third. You have to take that and you have to cube root it, because that's our a cubed. It fits into the identity, and now once I find a and b, I'll be able to plug them all in over here, and I'll be done. Okay. This is our 343. We're going to take the cube root to find our b and our a just like that. Okie doke. All right, I'm going to keep on going. I'm going to try to make it. I'll let you know that for the difference to cubes, it's going to be the same process. Okay, you're always taking the cube root. Here's the thing. Let's look. 27. You might have to use your calculator for it. You go here to your calculator, and we have to take the cube root. We're going to be using, where's the button? You see the button back here? No. You guys see the button right here? You see in the background it has x square root y. That's where we're going to put in our cubed root. And I think we do that by pushing 3. Second, get that, 27. Nope. It's, you put in the what's on inside the radical first, 27. Cube root 3. 3. Oh, it blinked. That's weird. So look, when we take the cube root of 27, we get 3. When we take the cube root of x to the third, we get x. And I could double check this. I could see, well, does 3 times x times 3 times x times 3 times x, as if we took a and cubed it, does it get us back to where we started? 3 times 3 times 3, 27. X times x times x, x to the third. So yes, we did it right. You can always check yourself right there. Yeah. All right, how about this? 343, we have to cube root it. I'm going to do it over here a little better so you can see. But then I moved everything out of the way. All right, you're going to put in the 343 first. You're going to hit second to get to that back button over here, the one in the background, by pushing second. And then you're going to push 3 because I'm doing the cube root. 7. So 7 times 7 times 7, that gives us 343. So I know B is 7. And C, let's double check ourselves. 7 times 7 times 7. Yeah, 49 times 7. 340 minus 7, yep. 343. I did it right. Yes. Do you see how it's just like plugging in? You could always, once you solve, you could plug it back in and see if you got it right. This is a test you can get 100% on, or this quiz whenever we get to it. Now watch. Here's where it gets a little wild. Wild and crazy. A plus B. A plus B. We did this part. We had it in this form. We worked it out, so we just found A and B, and now we just plugged it in. All right. What is A squared? A is 3x. 3x times 3x is 9x squared. So what did I do? I took my A value and I applied it right here. A squared. I take 3x times 3x. That's all that was. Right? A squared. I found my A value with all this work. And now I just went back. 3x times 3x, 9x squared. Good? Yep. Okay, let's keep going. Minus A times B. Minus, they're both positive, so we're going to just be able to put minus 3x times 7, 21x. I've done this, I've done that, I've done that, I've done that, I've done that. Now I got to do this. Last step. Lastly, we take B and we square it. 7 squared, 49. So what did we do? We identify which of our 3 options we're using, which one of our identities. We found A values because it's a cubed values. A cubed plus B cubed. We cube root it to find A and B. Cube root A squared. Cube root A cubed. Cube root B cubed. We get A and B. Then we just look at our identity. We started with this one because we were doing the sum of 2 cubes. And now we just had to do A plus B, A plus B. A squared, 3x squared. Minus A times B, multiply and make it negative. Plus B squared, take B, square it. Done. And that's all I can keep, you guys. I already went over, didn't I? Yeah, I did. Thumbs up, sideways, down. Let's look over this again. You know what? I'm going to, because we had the Halloween party, let me pause it. Actually, I don't want to talk about that. Ha ha ha.